Hello all. So this is a lecture series which is running under this is lecture number 5. Okay. Haloalkane and haloarenes. And this is based on your NCERT. Okay. 12th chemistry based on NCERT. Okay. As in this lecture series, I promise that I will give you concept as well as notes. So the running notes, you can write it down through this. That will be beneficial for your academic purpose. So let us start. This will be lecture number 5, haloalkanes and haloarenes. So today, to continue this, the second type of preparation, it is from alkenes. Okay, from alkenes. And do revise. Okay, do revise the concept whatever I taught you. So it will be easy for you to understanding upcoming reactions. Okay. So from alkenes, the first one will be your addition of hydrogen halide. Okay, addition of hydrogen halides. Okay, so we are adding this hydrogen halide. So first we will write up. Okay, an alkene is converted to corresponding alkyl halide by reaction with hydrogen halide. Correct? So we have this carbon-carbon double bond. Okay, and it is reacting with hydrogen halide. This can be HCl, HBr, HI, HF. Okay, so what is the product you are getting? Carbon, carbon, correct? Here it will be X, here it will be H. So halide and your hydrogen both added over here. What will be the mechanism, probable mechanism over here? So here it will be carbon-carbon double bond. And then we have this hydrogen halide. Now you just tell me which one will have partial positive and partial negative. So this is halide. So halide will be based on group 17. Hydrogen, it is group 1. So we are going from left to right. It means your electronegativity is increasing. So halide will have more electronegative than hydrogen. So here we can write this is negative, this is partial positive. Now if this one is partial positive, this will be act as an electrophile. We can say that it will be act as an electrophile. Now what is happening? This double bond, it is having electron rich center. So this bond is going and attracting this electrophile. By the same time, this bond will shift towards this halide. Okay. So in the first step, what you are getting? It will be carbon positive over here, and then carbon and hydrogen is attaching over here, right? So what is happening over here? It is like the pi bond is shifting towards this carbon, okay, where the attacking reagents is coming and attacking. Okay, in the next step, whatever you have this X minus will go and attack over here. So you are getting halide over here, carbon and hydrogen over here. Okay, so now for academic purpose this is fine, but for competitive examination they may ask you, can you tell me what type of effect is playing role over here? Okay, there are 4 type of effect, right? Name those effect. It is inductive effect, resonance effect, electromeric effect and hyperconjugation. So which effect is playing over here? See, as I told you, if this reagent is not present, this double bond will be stable, right? If this reagent is not, if I'll remove this HX, what will happen? This will be as it alkene. But if I'm applying this hydrogen halide, then only this double bond is shifting and getting this electrophile, right? It means we know that out of this 4 effect, only electromeric is having temporary effect. Temporary effect, okay? Out of this 4 effect, only electromeric effect is having temporary effect. So this is here also it is temporary effect only. See, if we remove this hydrogen halide, this effect won't play. Okay, this double bond will not shift. It won't go to any electrophile. Okay, So if electrophile is present, then only this double bond is moving. It means it is a temporary. We can stop this effect. If we are withdrawing this HX, hydrogen halide, your double bond will be as stable as. Okay. So now what is happening? We are just giving this electrophile and this double bond is shifting. Now, if it is electromagnetic effect, there are two types of electromagnetic. One is plus E, another one is minus E effect. Correct? Now you just tell me which type of effect it is playing over. See, for plus E, we know that the pi electron is moving to that carbon where the electrophile is attacking. So this will be plus E. It's the same thing is happening, right? This pi bond is shifting over here. So here it will be negative charge, and this negative charge is pulling this electrophile, and then in this carbon, this electrophile is attaching. See over here. It means this side, if it is positive, it means pi bond is shifted towards this carbon. So here we call it, it is a plus E. Minus E means the opposite carbon. If suppose your electrophile is coming and attacking over here in this carbon and your double bond is shifting to the other carbon, then we call it minus E. But here the case is the pi bond is shifting towards that carbon where the electrophile is attacking, right? So it will be plus E. To more get clear, we can say the conceptual for this electromagnetic effect, I am having a well defined playlist for that, conceptual chemistry. Under that you will find this electromagnetic effect. Go and watch that. It is very easy. You will come to know what is plus E, what is minus E, how the electromagnetic is playing effect. Okay, how we are saying that it is a temporary effect. Everything I have explained over there. Okay, so that will be playlist name is conceptual chemistry. So under that you will find this electromagnetic effect. Correct. So now this is the product. Now one thing, this alkene, we know that this alkene, we call it symmetric alkene. Okay, why this is symmetric alkene? This is extra I am giving. Okay, this is not required in your 12th, but whether, see, after 12th your dream will be either NEET or maybe JEE Main, right? So for them you need little bit extra than your NCERT. So that only I am giving. Okay, so it is, see, if I'll pass a plane over here, see both the side it is same, right? Both the side it is same. Suppose I am putting over here hydrogen, 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 hydrogen. See both the side it is same. So it will be symmetric. Symmetric means both the side of this plane it will be same. So it is symmetric alkene. And now this reaction, it doesn't play, like, it doesn't affect a role, or maybe we can say that you can add halogen over here and hydrogen over here. In the next, you can just shift this addition also. You can put over here halogen and put over here hydrogen. That is also can be possible because this is a symmetric alkene. Wherever you want, you can put your halogen and hydrogen, correct? But in this case, for asymmetric, this is your, see, this type of alkene is your asymmetric. See, if I am putting a plane over here, this side and this side, now it is not a symmetric. Okay, so we call it asymmetric or unsymmetric. Okay, so for unsymmetric, now you have to see whether the hydrogen will come over this carbon or this carbon. Okay, maybe your halogen is coming over here or over here. So that will be depend on your stability of intermediate. Okay, so reactive intermediate you have to go through with that, so you will come to know. Okay, but one well known name reaction is there where the halogen will go and where the hydrogen will go, that we call Markovnikov. Okay, that will call Markovnikov addition. Okay, so what is Markovnikov addition? Just write it down. Unsymmetric alkene when react with HBr, okay, that is hydrogen halide, it will give 2-degree bromide. 2-degree bromide as a major product. Got it? So this is your alkene CH3. Sorry, here it will be single bond CH, double bond CH2. Now reacting with HBr. So see here also, the based on the electronegativity differences from the periodic table, we are taking from periodic table. So here it will be partial positive, here it will be partial negative, correct? So now what is happening? This bond will, see, this bond can shift like, okay, anyway, two way I will represent. This is one way, this we call it root number 1. So here root number A it is following, and the product it will be, the intermediate will be your CH, here it will be positive, and here it will be CS3, correct? Both the root, your byproduct will be Br minus, correct? So now you are getting this carbocation. Now second root, this will be your root B. I'll change the color. Okay, I'll change the color. This is root B. What is happening now? Your here HBr I'll take. Okay, here partial negative charge, partial positive charge. Now it is coming from this side and it is taking this electrophile. Okay, okay. As soon as it is taking, the electron density will go with bromine. Here also the same thing is happening. So now you are getting CH3, CH2, CH2 and plus charge. Have you understood what is happening? See, this is your A, this is your B. This is your B product and this is your A product. Okay. If this makes the product Br minus, it will be your CH3, CH, CH3 and Br will attach over here and it will be your A product. And if this one is making product, what will happen? Your Br minus over here, this will is attacking over here and you are getting product CH3, CH2, CH2 and Br. So we know that this is minor product and this is major product. But how and why? Why this is major and why this is minor? Let us discuss. See, if you are moving this pi electron towards this carbon, what is happening? In this carbon, negative charge will be there and that negative charge is attracting this electrophile. So here it will be CH3, correct? And this pi electron is shifting over here. That means this carbon is having positive charge. See here, the same thing is happening. Now, this is root A. Now root B. What is happening root B? This is root B. Root B. Now see, this pi electron can shift this side also, right? This pi electron can shift over this carbon. So negative will be over here and positive will be over here. So now same thing is happening. So negative charge will be over here. So see here it will be from CH to CH2. This hydrogen is coming and attacking over this carbon and CH2. And if this one is shifting over this side, so this carbon will get positive charge. See, we are getting the positive charge. So if it is following root number A, you are getting this product. It means this is 2 degree bromide. And if this is following this route, it will be 1 degree bromide. Correct? Now this thing we have understood. If it is shifting to this side, then you are getting 2 degree bromide. If pi electron is shifting towards this carbon, you are getting 1 degree. But how come this is minor and this is major? See, here the main things. This is the reactive intermediate. We call it Ri, reactive intermediate. Here this one is reactive intermediate, right? Now you just tell me, this is a secondary carbocation. And this is your primary carbocation. Okay, according to your hyperconjugation as well as inductive effect. Even inductive effect also I have taken classes. You can see with that conceptual chemistry folder, that playlist, you will find that hyperconjugation also. There the stability also I have discussed, how the tertiary is more stable than secondary, secondary is more stable than primary, correct? The two processes are there, like through hyperconjugation also you will get it and through inductive effect also you are getting, okay? So here we know that this carbon is having 2 alpha carbon, alpha, alpha. So it means the carbon which has the positive charge, it is attached with the 2 carbon, 2 alpha carbon. So only we are considering the alpha carbon. So 2 alpha carbon means it is secondary. Here the carbon which is having positive charge is attached with the only 1 alpha carbon. If we are talking about this carbon, this is beta carbon, right? And we are not going for the beta carbon, we are just stopping with the alpha carbon only, right? So here the 1 alpha carbon is there. So 1 alpha carbon means we call it 1 degree carbocation, correct? So now we know that 1 degree carbocation is less stable. If it is less stable, it means this is forming very less. So if this one is forming very less, this reactive intermediate, your product will be also very less, right? That's why this is minor product. And we know that secondary carbocation is more stable. Okay, more stable compared to your primary carbocation. So if it is more stable, it is forming more. This intermediate is reactive intermediate is forming more. If this one is forming more, you are getting this is as a major product, correct? This is only Markovnikov addition, correct? Now, one more thing is that, so now if we are getting always this secondary bromide, what about primary? Okay, how we are going to get primary? That we discuss with the anti-Markovnikov. Okay, so in the next slide, we are seeing the anti-Markovnikov. Anti-Markovnikov's addition. Okay, anti-Markovnikov addition. Okay, so here also you can write it. Okay, because you need notes to write, right? So just you write that unsymmetric alkene when react with HBr. See, we are adding something in presence of hydrogen peroxide H2O2 and heat. If you are adding hydrogen peroxide and heat, your mechanism will be through radically. Okay, it will give 1 degree bromide. Okay, 1 degree bromide as a major product. See, there I have got 2 degree as a major product, but why I am saying here 1 degree major product? So again we have to see the what is the intermediate over here, and based on the intermediate we will get the product. Okay, suppose this is the reaction CH3 CH double bond CH2. I am reacting with HBr in the presence of hydrogen peroxide and heat. What we are getting the major product CH3 CH2 CH2Br. Why we are getting this as a major product and this as a minor product CH3 CH CH3 Br. This is as a minor product. Why so? Let us see the mechanism. Okay, so always it is required to understand the mechanism. If you know the mechanism, okay, you can easily solve the reactions and your product will be always correct. Okay, whatever product you are writing, it will be always correct. And to know the mechanism, what all is requirement? Requirement is your the basic organic chemistry, that is your electronic displacement, reactive intermediate and types of reaction. Okay, electronic displacement, reactive intermediate and types of reaction. If you have command over these three, you can easily say that how this reaction is happening, and with the starting material and reagent you can easily write the product. Okay, so those things required very much. So electronic displacement is the 4 type of effect, that is inductive effect, okay, electromagnetic effect, resonance effect and hyperconjugation. Reactive intermediate, your carbocation, carbanion, carbene, nitrene, carbon free radical. Okay, these are the reactive intermediate. If it is type of reaction, that you have to look into that SN1, SN2, SNI, E1, E2, E1CB, correct? So nucleophilic addition, electrophilic addition, okay. So these things you have to look over. So if you have command over those three, okay, that you will find in the conceptual chemistry folder. Okay, so now see the mechanism, how it is happening. So in the first step, what is happening? You have the H2O2, that is hydrogen peroxide, and you have heat. Whenever the heat and hydrogen peroxide, it will be there. This is highly unstable, right? Bond between this oxygen single bond, it is highly unstable. So what will happen? This is radically. This we call fish hook arrow. Fish hook arrow. So one electron it will go. So 2 molecule of your radical we are getting. Okay. Now this radical, what it will do with HBr? Okay, with HBr it will play. So this is OH radical. Now what is happening? See, this OH radical will be neutralized by this hydrogen radical. Okay, why? Because we are getting water. If this OH radical, this electron and the hydrogen is having this radical, this bond will also break, right? So hydrogen is having this radical. So this 1 electron and this 1 electron will make together one bond. So here OH, another H will come over here, and here we will get the water. Okay, it means how this thing is happening. See, from here we are getting this hydrogen radical, and from here this OH radical, this one is coming over here, this one is coming over here, and this one is coming over. So these 2 electron will make one bond. So how it is happening? Oh, so this is the new bond it is forming, and older bond is already there. So OH, this bond is forming. So this is the similar H2O we have written. Okay, and remaining Br radical is left over. Now this Br radical, what it will do? Okay, this Br radical I need in next slide because I need a bigger place. So now we have the Br radical, right? Now just write it down. This one in a middle. We have this reagent CH3CH double bond and then CH2. Okay, now we have the Br radical. Okay, so to get Br radical, this is the path A where the Br radical is there. Okay, so with path A, what will happen? And before this path A and path B, one radical will go over here, another radical will go over here. Okay, it means, okay, anyway, directly we can do it. Directly we can give it Br radical, and this is path A. So in path A, what is happening? This radical is going and attacking with the available radical. See, one electron is coming over here with this carbon. So this radical will go with this radical and it will form a new bond, and one radical will be left over here. So it will be CH3, CH radical will be over here, then CH2, and one bond it has formed. It is Br. Correct? This will be your product A. Now, next product, what it will form? This is your path B. In path B, what is happening? You have Br radical. What will happen? This Br radical will go and attack over to this carbon, and already this electron is coming over here with this carbon. So these two radicals together will make one bond, and it will be your CH3, CH. Here it will be Br, and you see you are getting CH2 and radical over here. This is your product B because path B we have selected, so it is product B. So once the Br radical is acting on this end carbon, another one is to this middle carbon. Okay, because this is asymmetric or unsymmetric alkene. Correct? Now you just tell me, this one is 1 degree radical. Correct? And this one is 2 degree radical. Got it? See, this free radical, this is alpha carbon, this is also alpha carbon. So 2 alpha carbon, so 2 degree radical. For this radical, we have only 1 alpha. This one is beta, right? So 1 alpha, so 1 degree radical. And we know that 1 degree radical is less stable and 2 degree radical is more stable. And again, I am telling you, if it is less stable, with this, again, one HBr it will take, and in HBr, see, this is the radical, right? So again, it will break radically. And this hydrogen radical will come over here. So you are getting CH3, CH, Br, and CH3. This is your, what we got in 2 degree. This is 1 degree radical. Okay, I'm not talking about bromide, but it is 2 degree bromide. The final product is 2 degree bromide. But you see, if this only the less formation, if it is less stable, means this radical it will form less, very less. So very less means this one will be minor, because it is also forming very less. Now, if this one is your more stable radical, so what will happen here also? You can take this HBr, H radical and Br radical. Now, what will happen? This radical will come over to this hydrogen and it will form a new bond. So CH3, CH2, and CH2Br we can write. So this is your 1 degree bromide. Okay, this is 2 degree radical. Okay, I'm not talking about bromide over here. So, but the product is 1 degree bromide. And if this 2 degree radical is more stable, it means in comparison to this 1 degree radical, it is forming more. And if it is forming more, your product will be also more. So that's why this is a major product. Okay, so simply don't mug it up. Everything is having reason. And one more thing, in chemistry, there is no exception. Okay, exception, it is not an exception. Exception means it's something special. You should know that why the particular element or particular compound is not following what you are thinking. Okay, it means it is having some special character that we have to understand. Okay, that's why we are eliminating this exception word over here, right, in the chemistry. That if hydrogen peroxide is there, then your primary will be more primary will be major product. Okay, if peroxide is not there, then your secondary will be major product. Why to mug up? Okay, mug it up. We already have the reason behind this, why it is major product 1 degree is major product in anti-markovnikov, and why this 2 degree bromide is a major product in your Markovnikov addition. We have the reason behind that, right? We know that this is the this reactive intermediate is stable, so we are getting this product. Here, this reactive intermediate is more stable, so we are getting this product. Okay, so again, I am telling you, you have to complete those basic organic chemistry. That is the 3 step. Okay, 3 basic organic chemistry concept you should know to solve any of the mechanism. Okay, organic concept you should know to solve any of the organic reaction. First will be your electronic displacement. Second will be your reactive intermediate, and third will be your types of reaction. If you are understanding these 3, your chemistry journey will be very much easy. Correct? I have started this electronic displacement in my playlist Conceptual Chemistry. There you will find these electronic displacements are further 4 types: I effect, resonance effect, electromeric effect, hyperconjugation effect. Reactive intermediates, we know that carbocation, carbanion, free radical, carbene, nitrene, and benzene is also there, but that is not required for 12th standard, but still this will be like bond. Type of reaction, we know that it is like addition reaction. Under addition, electrophilic addition reaction, nucleophilic addition reaction, free radical addition reaction. Substitution reaction, again for substitution reaction it will be SN1, SN2, SNI, intramolecular, that is SNI. Then you have even aromatic substitution reaction is also there, electrophilic aromatic substitution and nucleophilic aromatic substitution. Okay. Then you will have elimination reaction. Under elimination reaction, E1, E2, E1, CB. This is conjugated base. Okay, type of reaction. So if you know only this much, okay, this basic organic chemistry where the 3 concepts are there: electronic displacement, reactive intermediates, and type of reaction. If you know these things, you will be master of chemistry. And you can be able to solve NEET question, JEE Main question, or maybe it is advanced also. And okay, because I am targeting the 12th standard student and 11th standard student, that's why NEET and JEE I have told. But still, you remember, if you know these things, you can qualify your graduation based examination, that is IIT JAM. That also you can qualify if you know the basic organic chemistry. These are the concepts. It is not like that. See, this thing is required for understanding. Reactions is nothing. If you know this thing, you can form the final product in that reaction, right? So there are more than lakhs of reactions. So is it possible for a human being to remember all those 1 lakh or 2 lakh reactions? It is highly impossible, right? But for one person, it is very much easy to remember or practice these 3 basic concepts. If you are able to understand, if you are able to revise, if you are able to practice these 3 concepts, those 1 lakh and 2 lakh reaction will be very much easy, correct? And then obviously it is required your periodic table. One class I will take how to go through with the periodic table. Okay, one class I will take with that, so that will be very much helpful for you. Okay, so for today this much only. So thank you for watching. Thank you.